All right, mic check, I'm good. So I'm Max Ceron, CWB Association Welding Podcast. Today we have a really cool guest, Welding Podcast.
The show is about to begin.
All right. Hello and welcome to another great edition of the CWB Association podcast. I'm Max Ceron with you guys as always, and we're going to have a great show today. The guests just keep getting cooler and cooler, and today I got a buddy who I've known for a few years now in the scene, and we've had a lot of fun together at events, and his company's doing awesome things. So we got Gentry Wood with us today. And Gentry, how you doing, man?
Oh, I'm doing awesome. Excited to be here, Max.
Awesome. I'm glad that you're here. Now, I've known you through the CWB Association. I've met you a few times, and I've always been struck by how much fun and passion you bring to your life and your job. You always got lots to say. So tell me about yourself. Tell the listeners about yourself, a little bit about Gentry, like where were you born, kind of a little bit of your path leading into your job.
I'll give you the Coles notes. So I'm an Alberta boy, grew up in Edmonton in the shadow of West Edmonton Mall. So that's where I currently am right now. And I work for a company out in Nisku, which is just a short jaunt on the highway out to the airport. I'm a father of three. So I have a 7-year-old son, 3-year-old daughter, and a 1.5-year-old little baby girl too. So home life is busy, but of course, wonderful. As for my job, I'm an engineer. So I deal with process development, quality control, and actively doing research, finding new products that we can provide to our customers. So it's quite an exciting role because I come in every day, I'm constantly doing something different. If production is slow, I'm in R&D mode. And if production is high, I'm trying to fix problems and make everything better. So no, I absolutely love it. And I think that's the goal, or it tells you you're in the right place if you can come to work every day and with a smile on your face.
That's so true. And like for yourself, let's say, did you always know you were going to be an engineer? Like we've had lots of engineers on this show, and I'm sorry for the welders out there that are like, man, another engineer, you kidding me? But like, did you know, or was like, how did you fall into that?
Fall into it is actually a good way to describe it. So my dad's an engineer, so you would think, naturally maybe I would want to do what my father did, but that really wasn't the case. I'd never considered it. So maybe this speaks a little bit to my personality, but I never really had much of a plan. I knew I was going to university. I always just kind of thought, hey, I'll find something eventually. I'll figure it out. So I went to uni and I was taking just general science courses, and I finally got through my second semester of like plant reproductive cycles, and I was just done. And all of my friends at the time were all engineers, and so I was like, let me go hang out, party with the engineers, have a good time. So I transferred in, which was incredibly difficult, but I managed it just by the skin of my teeth. And then I fell in from engineering school. I found something I was good at. I excelled. I got really good marks. And then I met somebody we might talk a little bit more about, Dr. Mendez, who was just newly joined the university and started the Canadian Center for Welding and Joining there, where he was focused on welding research. So I took his third-year course in materials engineering on phase transformations. And he invited the class for a tour of his welding lab, and he's a passionate guy. I was young, starry-eyed, didn't really know what I wanted to do with my life, and one thing led to another, and now here I am in a career in welding. So that's my story.
And Patricio is an awesome guy. He's from Argentina. I was born in Argentina too, so I always try to get him to talk to me in Spanish, but he won't. He's like, "No, man, that's like outside of work." It's like, "What are you talking about?"
Yeah, how passionate and excitable he is. So it just breeds that into everybody that gets associated with him.
I watched him one time just start waving his hands and just getting all worked up talking about grain migration. I was like, okay, like, wow.
Yeah, stuff that makes other people's eyes glaze over, and he's a mathematician too, right? Like he's you know next level when it comes to the equations of welding, and he finds a way to be able to make people care, where you can look at a PowerPoint slide and it's got all these crazy numbers on it. And he's like, no, these actually mean something. And so that's always helped me, right? As somebody who kind of appreciates the academic side, to maintain that level of excitement, but put it in a context where no, it matters. Like it makes a difference, for how you actually are going to be doing your welding.
Yeah, for sure. And so you if you wouldn't have found that welding course through the CCWJ, what do you think you would do? Would you have continued with engineering? Would you have been maybe a mechanical engineer or something, or do you think you wouldn't have had the passion you have now?
Well, I'll tell you. So when I got into engineering, my grades were okay, but they weren't amazing. So they gave me the leftovers of what was available for space in the engineering program. So they said, you can either be, electrical engineer, computer science engineer, and neither of those appealed to me. And or you can be a materials engineer. And I was dating a materials engineer at the time, so I figured, more time spent with the girl I was dating, why not, right? And turns out that was a great decision. We aren't dating anymore, but it helped me find my passions. So I maybe it seems like from where I am, I was a man with a plan, but I very much just kind of floated from point to point to point to point. So I like to think that welding found me more than I found welding.
Awesome. So you came out of school then. You had the connection with Patricio. Did you use those connections to get into welding work right away, or did you cut your teeth in other engineering gigs, or like what kind of gigs did you have out of college?
Well, so I kind of found my gig in college. Patricio set me up with the company that I work for now, Apollo Machine Welding. And I got a job out at their laser cladding division, which is the one in Nisku. So I was a summer student. I came in, spent 4 months in their metallurgy lab, polishing samples. They affectionately referred to me as a polishing monkey, but I got really good at it. So when it came to cutting up metal and making it look shiny, that was my jam. And I came back the next year too. So I did 2 summers at the end of my 3rd year and then end of my 4th year. And then the company was interested in having a full-time engineer on staff that would, be in charge of quality and research and development. And they approached me, and so did Patricio. We all kind of got together, the 3 of us, and they were like, we could sponsor you to do grad school if you wanted to. And at that point, I had really good grades. I had a passion for, I was excited about the company because there was stuff they were doing with lasers and metallurgy, like what I'd learned in school. I had a good working relationship with them, and I'd spent a couple of semesters while I was in school doing research for Patricio. So we had a really good relationship as well. So again, it was one of these things where I was like, sounds like a good idea. Yeah, being a PhD, didn't really think that was for me, but why the heck not? Let's give it a try. And then fast forward 4.5 years later, and I was able to slip right in from doing my PhD into working for Apollo afterwards, and I've been here now coming up on 4 years. So I didn't have a whole ton of experience. I didn't go from company to company to company. I pretty much found welding, found Patricio. Patricio found me the job here, and we developed a good relationship, and it's something that I've used to build the beginning of my career.
And that's amazing. That's rare. That is rare for people to just kind of like come out of school and find their job that they kind of slide into and really enjoy it. I literally just was talking to a guy from South Polytech that he just left there, but he had same thing. Started in college, got a co-op through South Poly, ended up working there right out of college, and went back through the college for his PhD. He ended up being there like 25 years. And now in his, like, as he's approaching 50, he's like, trying a new job because he's like, you know what, I'm pretty comfortable and pretty set up, but I feel like I want to try something new. Your situation,
yeah.
do you feel like you could be there the rest of your life, 25 years, or you got hobbies on the side that keep you interested?
Right now I do. Yeah. Part of the excitement of all of this that's happened is, so the company sponsored me to go study the process that they're using, this laser cladding process. And I got knee deep into it for about 5 years. And when I graduated, they said, hey, you've done all this research. Why don't you actually try and apply it in production? And that never happens. Like, that is so rare, because normally you study something in your PhD and then you go get your job and you never think about it again. At the end of your thesis, you write this little, future work section that's like, if I could continue working on this stuff, what would I do? And it's normally a really long section because there's so many things that you didn't have time to get to. And I get to actually, crack that open and say, no, that's my job now. I get to actually follow through and try and continue to solve some of these challenging but awesome problems. So in terms of, do I see myself here for a long time? 100%. And there's so much work to be done on the research side and being able to mate that with production that, I'm not thinking of that far down the path. That's not really the way that I am, but I'm happy where I'm at, and I could see myself here totally for a long time.
So for a young engineer that's taken an engineering course, and I've had a few young guys on the show already who are young engineers, and some of them have a little bit of welding experience, some don't, but they're all kind of lining up for a welding career of some kind in engineering. How do they go about following your path? Like, how do they get into the the Center for Welding and Joining? What's the process for someone that's looking to get really specific like you did?
No, that's a good question. The easiest path at the university. So they're building their welding program right now. They don't have a dedicated undergraduate. You can be a welding engineer. The program is specifically dedicated for graduate students, so those people that are pursuing masters, PhDs. So the way that you get involved is at the undergraduate level, like I did, is you start doing some of these small undergraduate research projects. At the University of Alberta, they're called Dean's Research Award programs, where for a semester you get to do a 1 hour a week type project in the lab. So I did 4 of those. And while I was doing those 4 projects in the last 4 semesters of my program, that's when I was in the lab physically holding a torch, learning about all the equipment that we had, because the lab had ETA, submerged arc welding, MIG, TIG, like everything, friction stir welding. That there was such a variety of processes. So I was there just dabbling, learning a little bit about everything. And then I decided to pursue the graduate studies. So it was really about showing some initiative, getting in the lab, getting interested, trying to do these smaller projects, and then just naturally kind of letting that grow into what it became, my PhD and the career that I have now. So hope that answers the question.
I should probably get Patricio. I should probably get Patricio on the show someday to explain this better. But do they take a lot of students? Is there a lot? Is there empty seats there, or is it like a wait list to get in?
Well, Patricio is very selective of the students that he wants to pick. So the Dean's Research Award program too, it's kind of like a trial run, right? So you get to kind of work together for a couple of semesters. You're not put in charge of anything too critical. And the way that it's been set up is done with mentorship is a huge focus. So the graduate students that are there, the masters and PhDs, will take on the undergraduates that are interested in doing these projects and mentor them for the semester. It's a lot of work. When I was there as a master's PhD student, I think I mentored 30 students in those 4.5 years, and it's a lot of hours, but it's super rewarding, and it builds this community. So it's the next generation. Those students that came in and love it the way that I do become the next graduate students, and the cycle repeats. So the way that it's set up, I think, is fantastic.
So what about students out in Canada that aren't at the U of A and would like to be interested or in pursuing something like this. Like, I mean, the Center for Welding and Joining is a very unique lab and
Yes.
center. Those aren't available everywhere. So do they take students from other programs, or is there a process, or do
No,
you know?
that another good question. So there are people now that the center's been recognized internationally. There are students from all over the world that are trying to get in to this lab to work with Dr. Mendez and take part in the world cutting edge projects that are going on. So people will find a Patricio and try and get in, and a lot of times these students will come with funding from other countries. I think when I was there, there was kind of this half balance of us homegrown Canadians, about 50%, and then 50% of these international students that were coming in from Argentina, China, Bangladesh, like all Russia, all over the world. There's kids coming from everywhere trying to get into this program. So you brought up a good point, like for kids in Canada that are trying to participate at welding at this research level, graduate school or undergraduate, there's kind of some limited options right now. These programs are growing, but in Western Canada, we've got the Canadian Centre for Welding and Joining, and then in Eastern Canada, Waterloo is another hub for welding research. So, but that's quite a divide, like geographically. You either go all the way out to the east or you're stuck with us out here in the west.
I mean, people could always come work in my garage and do some research, but
That's the best kind, as long as you write it down and you apply the scientific method, man, do whatever you want.
So you talk about finding this passion for the students and the communities, and I think I see that now in your involvement in a lot of programs. Like, you are involved with your local CWB Association chapter as well.
Yeah, so right now I'm the chair of that chapter. So I've been on the executive now for, well, ever since I graduated. So it all started with the CWB Association has the student chapter at the University of Alberta. And from that, those kids graduate, and then the Edmonton chapter just sucks them up right away and brings them on board. And right now, our executive is actually 100% students from the CCWJ. Not that we're not trying to get other people, but
Hostile
whereas
takeover.
other yeah. Whereas some chapters sometimes say they have problems, bringing people on board. We decided this was a strategy a while back to say, now we'll just grow the people that we want and then bring them on board. They understand the CWB. They've been involved, for at least a couple of years. And the nice thing is all the kids that are coming in and graduating, they're excited, high energy. If they don't have a job, they're using it for, being able to create the connections and networking. And so we're pretty lucky. I love my involvement with the CWB in terms of being the chair of my local chapter. I also am the chair of the National Advisory Council, at least until September. So I'm serving out the second year of my term. And that one came a little bit differently. There was a transition, and there wasn't really a plan for who was going to take over next. I think it was Victor. Victor Edgerton. Yeah. And we were in the meeting, and we're deciding who the next chair was going to be. And they're like, what about Gentry? Let's get the young guys in. And I, in the spirit of always wanting to say yes and getting involved, I said, well, I don't really know what it involves, but I'm willing to try. And that's led to me being the vice chair and now serving on my term as the chair. So I also very much enjoyed that. It's a different position. I'm writing articles for the Weld magazine and trying to get stuff coordinated for our semi-annual meetings to make sure that the association is moving in the right direction in terms of the events that we're holding, and the executives are strong, and we're providing value for our association members. So I get to be on both sides, trying to make sure that everything is going right for the association, and trying to focus then locally on the Edmonton area and providing good, strong technical.
I've been preaching that, and I think I even talked to you about it a couple of years ago, that all the strongest chapters across Canada are ones that are tied to colleges or have a strong local secondary or post-secondary, networking system. And that's so important, because you can't just expect someone to join in out of the blue. You got to recruit, and you got to bring them in and let them see and let them spread and share the experiences, because then that creates the true network, right?
100%, man. The community is everything. And so before I really came on board in these kind of leadership roles, like I've been associated with guys from the CWB now for almost 10 years. So I really got a chance to meet the people. We would host our annual conference, the Can Weld, before the world ended, and we'd go across the country and just hang out and get to know each other and say, hey, what are you doing on the East Coast? We don't get to see you guys or talk to you guys that much. How is welding different over here? And what are you guys working on? What do you care about in the West? It was just a wonderful event to be able to meet people and foster that community that really is kind of the hallmark, I think, of our association.
Yeah, and we're gonna bring it back. It's gonna come back. We're gonna make it grow. But it's time. It's a good time for our commercial breaker. So we gotta take a little break for our sponsors. So thanks for tuning in for the CWB Association podcast. I'm Max with Gentry, and we'll be right back after these messages. All right, and I'm back. This is Max with Gentry on the CWB Association podcast. Thanks for tuning in. We were just discussing the merits of the CWB Association and networking, and also getting students involved. Now, let's move forward from that, because you are now in a leadership position. Like, you're now working for a very successful company. I did a little research on Apollo Machine Welding, and it's a big company, although there is a lot of other companies called Apollo.
Yes, yeah.
There's actually another Apollo Welding in Saskatchewan.
Even within our own company too, there's a whole bunch of different branches as the company has grown. So there's the laser cladding, and there's the threading division, and our machine shop in Edmonton, and like everybody gets confused because we offer so many different services.
So as a start, like, I was just reading the history, and this is before your time, but it started off as a machine shop and seems to have grown from there. So right now,
This is our 50th year. Pretty exciting.
In your location, what's the gravy? What's the main meal ticket that you guys do in where you work?
Okay, so the division that I work out specifically does laser cladding. So that's using a laser, high-powered light, essentially, to be able to deposit wear and corrosion-resistant coatings. So we're in the business of hard-facing to be able to provide increased lifetime for components. So our machine shop does a lot of manufacturing of directional drilling components, and a lot of those components will come to us to be able to hard-face certain components that are damaged during drilling or subjected to really aggressive environments. Or we get stuff that comes back from the field to the shop that needs to be repaired, where the majority of the component is good, and we have the opportunity to use this technology for rebuild. One of the cool areas too that I'm working on that isn't really a meal ticket right now, but I think is exciting and is going to be the future, is we can use this same laser cladding technology for additive manufacturing. So we're printing metals in production. So, for a business that for 40 years was exclusively focused on subtractive manufacturing, on machining, they definitely saw the value in investing in, well, what if we wanted to do the opposite? What if we wanted to add material, instead of remove it? And I'm here to try and build the business case and demonstrate that you can do that and generate sound parts. So there's a lot of exciting stuff going on right now.
Okay, so for the layman, like, I mean, not total layman, but the average welder who, 99% of welders have done cladding and surface buildup of hard facing material on some type of component. Like, you're building up shafts, you're building up bearing races and housings to get machined down and get reused. That's a very common part of the industry. Now, you're saying that you can do those same jobs with the laser cladding, or is this like different setups? Or like, like, are they competing in the same game, or is this very specific type jobs that you can do?
No, we can compete in those same markets as well. Building up bearing racetracks and some of those things, and remachining are things that we do from time to time. The challenge is it all depends on what you're building up and what the cost of the component is that you're repairing. So the laser cladding repair is a little bit more expensive because the equipment is like an order of magnitude more expensive than a welding machine. But there's things that you can do with lasers that you can't really do with traditional welding, particularly when it comes to dissimilar metals. So I'm able to apply materials, not get the mixing as much because I have a little bit more control with the laser beam. And I also, in some cases, have a bit of a productivity advantage because I'm taking advantage. Everything is as automated as possible. We're using robots and CNC machines in order to be able to apply these coatings, and we're driving the productivity through automation. It's really difficult. You can do it. I've seen some stuff where guys have handheld lasers, but for the most part, we're working in an automated world, trying to deposit these coatings as quickly as possible.
Well, that's like the Twitter feed right now, is that little handheld laser that they're showing. Have you seen it?
Yeah, from IPG.
Yeah,
So,
it's pretty cool. I don't know how useful that is, but it is neat.
We're looking at it. We're trying to see if we can find an excuse to just get a handheld laser, mostly because of the child in us that wants to be able to just hold a laser gun and just go pew pew and
I got to use one in
use it more as a toy than actually as a production option. But
yeah, when I was at FabTech, I was there with Doug, and we got to play with some handheld lasers, and it was actually a lot harder to line it up because they're like so specific, right? You're like, there's a weld, and you're like a quarter inch away from the seam. It's like, oh, whoops.
When it's non-contact like that, I've seen some pretty awesome videos. We do some welding, for the purposes of joining here, but not a ton. But some of the coolest videos that you'll see online are for automotive welding, where you've got like a car door and you've got a robot that's manipulating the door, and then another robot arm that's holding the laser, and it's doing like
Just
20-30
by.
welds a second across the room, and it's just this dance that they're doing. It's super cool technology, but you can imagine it takes you a little bit of time to be able to set something like that up.
So I'd imagine with the laser cladding, you're going to be way more in control of the heat input, the joules. So that's going to control distortion better, the depth of mix, all those things. Like right off the top, they seem like, okay, that's why I would use a laser. Now, obviously, aside from cost, what's something else that you really got to worry about when you decide to go to lasers? What's something that you would say is an obstacle in deciding to go to lasers?
So maybe a couple that I've struggled with a little bit myself. So we're really sensitive in some cases to the prep. So I need to make sure that, my part that's rotating beneath the laser beam, because we do a lot of cylindrical components dealing with these directional drilling tools. I need to make sure that that's dialed to within, 10 thou. So we're dealing with, tightly controlled processes. If you're welding, distances that are less than a millimeter matter in terms of making sure that your beam is on the joint where it needs to be. So fit up, you got to spend the time to make sure that things are precise up front in order to be able to get the quality, because as soon as stuff starts to wander, it's a welding process that everything is related. One knob affects, 5 different outputs, and you can end up with something that's not desirable if you're not careful. I would say one of the other challenges, something you got to worry about, is when you're doing complex parts. In an ideal scenario, maybe that it's a new manufacturer and you've got a CAD model for the part. You can program the path that you want the laser to travel in advance. And right now we're in the process of really diving into and getting better at doing this tool pathing, so we can program stuff not while the part is on the laser and say go from point to point to point, but to then take full advantage of the, the computers and the capabilities that we have today to be able to do that in advance, take your program from your laptop, plug it into the robot and have it, be ready to go, and avoid all that wasted time and doing that work on the laser, not using the laser for what you want to be using it for.
That leads me to like this, it kind of puts you down a rabbit hole once you start getting into this world of high technology and wanting to stay on the front end, because it kind of forces you to stay there. So you're constantly having to look at new processes, new equipment, scanning systems, seam tracking, robotics, articulations, cobots versus robots, all this stuff, just to stay relatively important in industry, or else someone's gonna slide past you.
Yeah, exactly. So we're pretty lucky. Here at Apollo, the company got a head start. So we've been looking at this technology now for about 13, going on 14 years. And there's nobody else around, at least here out west, and that is competing in the same space. So we've got a head start in the industry, which is great. But you're absolutely right that in order to maintain that head start and that competitive advantage, we need to be constantly innovating, looking at new capabilities. One of the focuses that I've had is incorporating thermal cameras into our process. So if you're welding at 250 inches per minute, you can't really rely on an operator to be able to look at the puddle, see something that's unacceptable, and then make a change manually, because at that point you've got like several inches of bad weld that you're going to have to carve out. So we need to be relying on sensors with automatic feedback control in order to push this productivity and then get the result that we need for our customers. So I get to look at some of that kind of technology and then spend the time figuring it out and incorporating it into production. So that's part of the job that I love.
Yeah, you're basically playing with the coolest new toys all the time.
Oh, exactly. So how can you get bored when you're constantly, you start with something cool, lasers, and then you add other cool things like thermal cameras and all these crazy sensors. It's just something that I think keeps me young.
So how much setup time is someone looking at? Like, you're talking about this precision and fitting, and like if I just had an aluminum can and another aluminum can, and I put them bum to bum, and I want you to rip a weld down the center. Like, am I looking at hours of setup for that, or?
I don't think so. I think we for some of those simple geometries, we've got good systems in place to be able to do that in maybe a couple of minutes instead of a few hours. If you have a part that really starts to have some complexity to it, or maybe it's small and intricate and thin walled and some of these kind of things, we might need to spend some time up front developing fixtures to be able to make sure that you can do a part and then put the next one in easily, and you get a quick change over time.
Get the repeatability.
Yeah, exactly. So, and when we're starting to look at other markets outside of oil and gas, dealing with stuff like mining components, agriculture, they have a lot of issues of wear as well, and farm equipment when they're doing the harvesting and hitting rocks and all those kind of things. So with those kind of components where we need these high productivity rates and high turnarounds, and they're more trinkets than they are full drilling tools, we're always thinking about those kind of things. How can we do this in the most cost-effective, high productivity way? And sometimes it's not focused on just the laser parameters. It's focused on how can I make sure that I put the next part in as quickly as possible, and fit up isn't my rate limiting step.
Yeah, and working in the mining industry here in Saskatchewan for so many years, especially with potash, which is just absolutely so corrosive. Where the wearing of parts and the rebuilding of parts, and even being able to like line bore and re-weld in the field and stuff like that with hard surfacing, it's a huge part of the industry. and I could see already, like, like some of those parts in my mind. It's like, that would be prime candidates, especially for stainlesses and stainless mixes. Like, I mean, the duplex world is just huge now,
Yeah.
and all that, and all the different types of, either homogeneous or mixed metals. Now, in terms of welding ability, the machine, what's its minimum size weld? What's the smallest weld it can do? And then what's the largest weld it can do?
Okay, no, those are great questions. So small welds, man, you can go down to maybe a millimeter, or even a little bit less if you've got a really high quality laser beam.
Mhm.
So we don't typically go down that fine, but for some of the autogenous stainless steel welding that we do, uh, we're down to 1 or 2 millimeters. They're very small, tiny welds. Now, for as large as you can go, that's a great question, and I'm always kind of asking that because if I can deposit more material more quickly, my productivity goes up. So I'm constantly trying to drive, how do we make this bigger? How do I deposit more material more quickly? There are systems out there that will deposit 50 millimeter wide beads in one go. So that's a very wide
That's like subarc range.
deposit. Yeah, and we're in the world of coatings, you're about a millimeter or two thick per pass, but still you get some excellent productivity out of that. For me, the typical width of some of these coatings that I'm dealing with, they go up to about 5 mil. Is typically the width, and I'm depositing a millimeter thickness at a time. So, and then by going overlap by overlap of beads, I'm able to coat large surfaces. And then if I get into my 3D printing world, this additive manufacturing, I go layer by layer by layer to then build a feature typically onto an existing part. So, yeah.
And then what type of lasers are you guys using? Are these like CO2 lasers? Are they like what, fiber lasers?
Oh, great. Another good question. So when I showed up here, and all the research that I did for my PhD was all focused on CO2 lasers. So using these old school gas driven lasers for processing, and you'll see some of them around now, but pretty much everybody in the industry has gone towards these solid state fiber lasers. The reason being is that the equipment is smaller. It's way more energy efficient just for how much energy it takes to generate the laser beam. And it's got an additional energy benefit, which is the wavelength of the laser is shorter by about a factor of 10. And you get more laser energy absorbed by typical materials, the steels and stainless steels that we're typically coating. So you start coupling together all those efficiencies and start looking at your utility bill. The cost justification kind of makes itself. So we don't have any CO2 lasers anymore, but we do have 7 fiber lasers in the shop. And we have a one diode laser that does fiber delivery. So it's a diode coupled fiber laser. So that's the way the industry has gone. That's the way Apollo has gone, and yeah, it's the way of the future.
Now, in the world of cutting with lasers, I know that the reflectivity of the materials is a big part. Is that also an issue in welding? Is the possible reflection or refraction of the light?
The reflection is a bit of a concern. For the most part, for the stuff that we're doing, we are able to capture about between 60 and 70% of the energy. So you have 30% that's lost. That is a little bit of a safety concern. So, we do have barriers in place, and there's special glass that we use to be able to keep people safe from any possible reflection.
Mhm.
When it comes to cutting, that's a good question. So cutting is something that we're just starting to kind of dabble in. It's a little bit of a different world, but we recently purchased a cutting head to just try.
Mhm.
And yeah, you're absolutely right. You need to be able to. You're much more worried about generating that puddle and then having enough gas flow to be able to expel all of the material. It's just a bit of a different world to live in, and we've had some fun playing and dabbling, and it varies whether you're doing steel or stainless or aluminum. you kind of have to learn the nuances of each material. So no, cutting is also another, it's widely used. Laser cutting is great. It's precise, it's fast, non-contact, which are all great things. But it's not something that Apollo's really heavily into right now, at least.
Okay, now the principles of the science of welding of metals, I'd imagine, is the same across the board. So a material that conducts electricity really well, has a high thermal conductivity, it's probably harder to weld with a laser as opposed to something with a low thermal conductivity that'll maintain more of the heat in the puddle. Is that, does it go the same across the board? So a stainless would require less energy to weld versus an aluminum and stuff like that?
Yeah, you're absolutely right. So those kind of material properties will impact your choice of parameters to be able to output kind of in theory the same result or the same weld. So aluminum with high thermal conductivity, you might have to apply more energy, but then you're not only thinking about thermal conductivity, you might be thinking about the melting temperature, which is significantly lower than steel. So it's kind of this this paradox where you would think you would need less energy because it's got a lower melting temperature, but you need, you also have the fact that it pulls heat so quickly. So maybe you end up running it exactly the same. So each material, when you need to look at it in terms of these material properties and your process parameters to try and figure out something that works for within each class of materials. One of the cool things that's kind of been going on at the University of Alberta is they've been trying to focus on the science in a way that maybe you don't have to be a steel expert or a stainless steel expert or aluminum expert. You might be able to have this theory of everything, that these equations that you can plug the material values into and still get meaningful results. And that was something I was a part of in a really small way, and something that I'm trying to apply now in my current job, because if a new material comes in, you don't want to do all the development again. And, maybe the starting point, the way you've always done your laser cladding, doesn't work for this material. So we can use this type of theory and this type of understanding to it kind of give us a head start, at least on the engineering side, to figure out where should we be operating.
That's exactly where my next question was going to go. Cause like with all the work you've done with your PhD and all the people that are working on these projects, you'd almost think that there'd be like, the app, where I can be like,
Yeah.
three-quarter inch
Yeah.
material. I want a 4 mil weld, and I got a 60,000 megawatt laser. I don't know how it works, but and then I just got to hit 7, 10, and 11. Oh, there we go, it's done.
Yeah.
I see it's still a dream.
It's in the works though. I've seen some really awesome stuff, and putting it all together in a meaningful way, it's a huge challenge. So the way that it's worked up until this point is you make all these assumptions and you come up with the minimal representation of what welding is, and then you're able to say something meaningful.
Mhm.
I can predict how wide my weld is going to be, or how fast the metal is flowing inside of the weld puddle. And then you start to add the complexity of maybe that assumption wasn't the best. Maybe my heat source isn't an infinite point. Maybe it's actually got some size to it, like a real welding arc. And then you have to redo all of the analysis. So to be able to get to a point where you're factoring in things like, I'm using this shielding gas and my material thickness is this, my geometry and my preheat have this effect. All of these variables that we have, it adds a ton of complexity, and it takes time. So do I think it'll happen in my lifetime? Yes. Is it ready right now? No. But I'm on a mission to, at least in a small way, be a part of putting something like that together at some point.
Well, even the science that I've seen on the new material testing guns, where you can just walk up to a piece of material and give it a freaking zap with the gun, those XRF
Yeah,
guns,
then you
gives you a full
you're able to
material
use
component.
optical emission to figure out what the chemistry actually is. We just got one of those. I haven't played with it yet, but it's super exciting.
Yeah, like
Everything that you
it's
can
so
do.
much relevant data at the touch of a trigger, instant, that you could just use for something else. It's mind blowing. Like,
That's one of the aspects of having all of these sensors for our process that I love too, where all of these really difficult things to measure, if you get all this information at your fingertips instantaneously, this is stuff that sometimes, as a metallurgist, I have to spend, days in the lab to cut a sample up and take a look at it, and then try and remember what I did a few days ago in order to get to the next step. Whereas if I instantaneously know all these things I care about, the machine will make the right decision for me. Obviously, I don't put all of my faith all the time in the machines. I do like to, us humans can steer the ship a little bit, but having all these tools and things accessible to us with the advancement of the technology and the commercialization of all these technologies is amazing for me as an engineer. Makes it really exciting. The future is bright.
Awesome. Well, the interviews we're already coming up on 45 minutes. That flew by, Gentry. And
it's fun talking to you, Max.
Yeah, we've had a few good conversations over beers over the last few years, and I'm sure we'll have many, many more.
I'll hold you to that.
So in heading out, I guess, is there anything you'd like to say to your community or to the people listening, from Gentry to the world?
Oh, maybe I can. I think I would probably encourage anybody listening, particularly the students, where you're at a point where you're like, this seems cool, but it's a little bit intimidating and there's so much to know. And, there's welders that have been doing this for 50 years and how am I ever going to figure all this stuff out? I would say the people are amazing. Give them a chance, and to not be too concerned that it's more important to just get involved and dip your toes and try and be as enthusiastic you can and just get involved. And it's that involvement that makes all the difference, or at least it has for me. I got involved in welding in school, and that led to a career that led to my current involvement with the CWB. And that's still what drives me now. Is it's just great to get involved and good things happen. So that's my spiel. That's my message to the world.
Well, and that's a good message. And so everyone that's listening, make sure check out your local CWB Association chapter. We're all across the country. Make sure you get joined. It's free right now. Contribute, help, volunteer. The networking is like none other in the world of welding. It's really important.
And check out right now, we have the unique opportunity of all these events are online. So I can go check out an event that's happening in Thunder Bay, being out here in Edmonton. So the fact that all our content while we've been shut down has gone online means that you have access now to stuff that has kind of been geographically prohibitive up until this point. So, as crappy as COVID's been, it's been really exciting to be able to participate in the association in a new way over this last year, and it's only getting better.
Yeah, and we got lots on the work. So we got an event in Regina in February. I think you guys got one upcoming in March.
Yeah.
So you guys tune in, and make sure you guys download these podcasts and share them. They're on the iStore, they're in Google Play, they're in Stitcher, and check them out on YouTube. And they're always all the content, and we're actually in the process of categorizing our entire library at CWB for online resources. So you have no idea the amount of wealth of information the CWB has in its 100 years of existence, and you guys as members have access to it. So take advantage of it, and I hope to see everyone involved. And Gentry, thank you very much for being on the show.
Yeah, no problem. My pleasure. You're the man, Max. This has been great.
All right. Well, I'll talk to you soon. You take care, and thanks for all the listeners.
We hope you enjoyed the show.
You've been listening to the CWB Association Welding Podcast with Max Ceron. If you enjoyed what you heard today, rate our podcast and visit us at cwbassociation.org to learn more. Feel free to contact us if you have any questions or suggestions on what you'd like to learn about in the future. Produced by the CWB Group and presented by Max Ceron. This podcast serves to educate and connect the welding community. Please subscribe, and thank you for listening.